Well, good morning, everybody. After that wonderful start there this morning with a talk on Raspberry Pi and learning all about coffee and everything else, those of you who were here yesterday at the Django talk will know exactly who we've got here. Amber Brown is going to talk on Twisted, I think, this morning. No? I did all my research and I've forgotten.
Okay, well, I'm talking about compositions, which is something Twisted uses. So.
Right, okay. So, would you put your hands together for Amber?
Hello, everyone. Everyone good today? Who went to DjangoCon and saw me yesterday? Okay, actually, I thought that would be... okay. So, hello. I am Amber Brown. I'm better known as Hawkie or Hawkie on Twitter, if you want to listen to stuff that no one cares about. I am the release manager, core developer, Python 3 person of the Twisted project, which is an open source asynchronous networking framework. I also spend a lot of time working for Testability on the Crossbar.io WebSocket router, which uses Twisted heavily. So I've been working on porting that to Python 3 and improving user experience, and it's really great and you should check it out. Now, it's pretty much a given that no software will stay the same. It is unchanging. Well, no software is unchanging. You will need to extend it, you will need to improve it, and you will need to replace it. That is the life cycle of any given software. Not all software is just a library. Sometimes, not all software are applications. Sometimes they're libraries, things that aren't used directly. They don't rarely do anything on their own, but everyone uses them. You can't really get much done these days in Python without using a library, whether it's Django or Twisted or Tornado or PyTZ, because time zones suck. And a lot of these frameworks recommend that how you extend it is use subclass. Now, for example, Django does this. It provides a list view. You subclass it, you override whatever functions to do whatever you want to do. You can write mixins that alter the behaviour and reduce a lot of duplication. For example, we have one in Twisted that we're trying to phase out, which adds some nice helpful things when you call string on it or when you call refer on it. So that is duplicated in a lot of different classes. So at the time we made a mixin which reduced that duplication and made it only happen in one place. This can lead to problems though. Multiple inheritance especially can lead to very confusing situations. And there's an instance where the order that you define the mixins and the subclasses actually changes the behaviour of the object quite drastically. There's some instances when you're using Django-based stuff where you actually have to be careful about the order, because otherwise you will have something that overwrites something else, and then it just won't work and give you rarely cryptic errors. Large inheritance trees like Django, I swear I'm not picking on Django, it's just the biggest one I've used and something everyone knows. It can be very confusing to navigate. I mean, there's things like class and class-based views, which helps you navigate what everything does, but it's like a tree with like 9 members. So it's really confusing. So I think you should say, slow down, compose yourself. Now, why should you slow down to start with? Well, software can only be designed once. And desirable traits can only rarely be designed in. You can't bolt on security, you can't bolt on performance, you can't bolt on modularity. If you try and do these things after the fact, when you have a significant amount of software, it will either fail, be suboptimal, or provide lots and lots of headaches. It is possible, but at that point it's easier to just rewrite it. Now modularity, especially if you're writing a library, and testability, if you're writing an application, are two very desirable traits that everyone should try and get. Modularity is pretty much the same as extensibility, because you want to have modules that could have extended behaviour. And this modularity actually quite helps testability, because these modules can then be broken up and tested in smaller pieces. Now, one of the things that Twisted has in its sort of manifesto of sorts, we don't really have an official one, is that tests are the only way to verify that something works and that something will keep working. We have a large test suite with thousands of tests running on platforms as diverse as FreeBSD, Ubuntu, Windows somehow, and we need it to keep working. So we have these tests to make sure that even small things that you might not think actually affect anything don't trigger a kernel bug in Fedora 19. Now, when designing a system, you want to aim for these traits. When you're designing it, you go, I want this system to be extensible. I want it to be performant. You don't have to go for all of these traits. Sometimes it's better to be understandable rather than performant. Now, why should you compose yourself? Composition is when logic is made out of small blocks of logic, and then you put it all together. This is in contrast to inheritance, where you have logic, and then you subclass it, and then add more logic on top. You sort of build on top, like a sort of a pyramid. Now, in composition, these blocks are down sort of component lines, so they have their own thing that they care about. One object does one thing, nothing more. As an example, a blog. It has multiple components. You have blog posts, so you have post, and you have the thing that gets the posts. You have user accounts, because you might want pluggable authentication, so you can connect from GitHub or WordPress or whatever. And you have comments, so that angry people can tell you why you're wrong. At runtime, these will be taken care of by an implementation of that component. Now, you don't always have to have the real things. During testing, you can mock it or stub it or fake it out. There's differences in these, and I recommend when you're doing your testing that you look up what each one defines, because they each do slightly differently. But replacing the real components with fake ones reduces the area that each test tests. Now, that might sound like a bad thing. You might want to test a lot of things. But if you have fine-grained tests, you know exactly what went wrong. When you have one test failure, then it's a very specific one. It's not in a bunch of other stuff that might be unrelated. One failure might cause, in a system where you do a lot of big tests, one little failure, like a syntax error in some file, might cause a whole bunch of tests to fail. While if you make them all small tests broken up, then it's more likely that it'll only make a couple tests fail. It's more localized. Not a lot of noise that you have to sort through. Now, fake components, a really good thing is that you can hardcode them to give hard to reproduce results. Now, if you're using something like Postgres, if you're writing a database layer for Postgres, you might want to, if you're running an ORM, for example, you might want to simulate something like a integrity error. Now, doing that on a real database requires you to make a database, make something, make a schema, and then violate that schema. But if you have a fake component, you can just make it return the integrity error directly, because it doesn't matter that where it came from, it's just that it raises this error in your logic. So no more space, integrity error, things like that that are really hard or make you have to do a lot of expensive work, like setting up a whole database, can all be faked away. So you can actually test that your code handles that without having to do a lot of tests, a lot of work to get the tests. Now, this means that you can go from having things that do real databases to ones that use fake databases, and you can make your test run in sub-second latencies, because you don't actually need to do all that work. Of course, in integration tests, you will want to do all that work. So it's about testing at a lot of layers. You want the fake components, but you also want tests to make sure that everything fits together. Now, why should you compose? Oh, the benefits of composing yourself. Now, inheritance, multiple inheritance, confusing. And the inheritance trees become very large, as I mentioned. Django is a major offender of this. Now, when you're testing, one thing you might be able to do is modify the MRO, or the method resolution order, or something like that. I don't do a lot of inheritance, so. But you can modify it. There's some secret things you can do, and you can make angels cry when you do it. But you can do it. But it's very fragile, it's very magic. Now, when you have composition, you have very big trees still. You still have things that do a lot of small things. So you're going to end up with more of them. But it's simpler to understand where each one fits in. If you can't switch out the components, you might have to monkey patch things. You might have to monkey patch away a database access. You might have to monkey patch away something that you can't actually do on your test environment. If you're testing in Jenkins or something and you can't set up a MongoDB instance, you would have to monkey patch in effect. It's also very fragile because it relies on implementation details. If something underneath changes, then the assumptions that your fake and the assumptions that your monkey patch makes might be wrong. It's also quite messy, and it can get confusing when you're changing things everywhere, and what's the real component and what's the component you've put in, and what if your component is buggy. So yeah, class-based views can be a help, finding exactly what you need to monkey patch and what you need to override. But you still need to worry about the internal state. You still have to read that code and figure out what it changes. Whether it changes some internal flag to say that a request has happened. And you end up with just these massive, massive objects when you use inheritance. Things that do a lot of stuff. And of course, you can end up with mixins that conflict with other mixins, because that's just great, it's fun. So, how do you do this? Well, you want to write an example of your code being used, if you're a library author. So here's an example of something called Vertical. Don't read into it too closely. It's a web framework I'm working on in my spare time. So for example, I've on here, and this is how I want the API to look. Ideally, once you've finished it, that sketch will run. Now you can find defects with this. You can find out, okay, when I want this, I actually need to give it this other value, or it has some dependency on this that I didn't see before. And you can design the API experience, which is really, really important. You work down from there. You go, here is what I need, how do I get there? We'll go back to the blog example. The 3 top-level components, the blog posts, the accounts for the authors, and comments for simple discourse. Now, you want to write interfaces for all these things, the objects that take care of these roles. If it doesn't cover anything, just expand it later. I mean, you're still in development, everything is changing. They all share a common component, storage. Now, each object doesn't need to do its own storage. You can have one storage object that serves all 3. So of course we need an interface for that. So here's an example of the interface for a blog post. So as you see here, we have it descends from interface, yes, it's subclassing, but that is zope.interface. It's one of the things that you can use, you don't have to use it. You define attributes, you say that these will exist on the object and these are what each means. And then you have the actual object that creates an interface. So you have a get post, a get post, and an add post. And it defines what you call it. And then if you want to define an even stronger interface, you then write doc strings that say what it returns. And as an example for accounts and comments and storage. So ideally, we have these interfaces. So we've got these now. So ideally we want some implementation so we can actually use it. Now when we're writing it, we don't have to write against production things immediately. In development, especially in Django, a lot of people use SQLite as their local database because you don't need a full Postgres server when you're developing. Now, when your database is something like RDS, that might have some special extensions. Postgres, you won't be writing against it right away, unless you want to put it in the cloud and upload it to Amazon every single time you want to do a change, which isn't very fast. So let's make it in memory one. So here's the code. Don't read it, it's horrible. But essentially, this is a very, very botchy, maybe 20 minutes in memory fake. But what this means is that now that I have a database, it is a close enough approximation that meets that interface. I can work on everything else. I don't need to worry about set schemas or migrations or anything like that yet, because I have an interface that works exactly the same, mostly the same, except it just works in memory. So no setup required, just load it. Then we want to make the actual log object. So this is a concrete interface of that. We call the storage, we get the rows of the blog post, we get all of the blog posts, and then we return. Of course, every blog needs a web interface because it's a web blog. And because we're just using the in-memory database, we'll just add some accounts and add some posts right there. We don't need to actually write it out to a database. We don't need a live database. We'll then add the web UI, like here. So just simple, very XSS prone web code. So don't use this in production case. And then we run it, and what do we get? We get this. Now it doesn't matter whether we're actually talking to in-memory, or talking to SQLite, or talking to Postgres, because when you're finished, all of those objects will have the same interface. So you can just swap them out. You can get close enough for now, and then put it on your fancy database later. Or you can have a specialized blog that does something different. It still meets the interface. So if you have a system that takes a blog and puts a web interface on it, you can just pass it to it and it won't care. But isn't it a bit overkill to have interfaces that will only have one implementation? What's the point of an interface? It doesn't seem like you could have these specialized things of iBlog. I mean, it's a blog, how many times can you implement it? Well, if you adhere to these interfaces, it brings a bit of a new way of thinking. You could have many implementations of iBlog. For example, a special blog that iBlog that only looks at the year it was instantiated and only returns things within that year. So that's your year archive. So that can just adhere to that interface. So instead of filtering or doing that, you just have one object that does just that, and then you pass it in at runtime. You end up having all these simple objects that do just one thing, and you sort of fit them together like Lego bricks. You build your little house, you build your little plane, and there you go. Now, testing. Now, one of the main reasons why it's great is that it makes things a lot more testable. It rarely does. So you can make simple fakes in the testing. That just gives you the result you want. So like before, you make exceptions, or you make things that are impossible to happen. Because you can't test those things that don't come up a lot, because then you have to rank your systems into reproducing it. But you don't need to actually make your machine run out of memory to trigger an out-of-memory exception. You want to test the components in isolation. For example here, this is just a snippet of some tests. You have your in-memory storage, and you test that it actually works the way you think it does. So if you were to use this again, you can know that it actually works. Then you start testing with the components built up. So you would have a log test, which would have a storage, or an in-memory storage. And then in your integration test, you have one that actually speaks to a database. And then make sure that you have correctness at every single level, that each part is tested, each part works on its own, and that when they fit together, they all work in concert. Now, I've mainly been talking about object composition. That's what I'm doing with the interfaces here. But you can just pass a function, because functions are just as good. This is called function composition in contrast to object composition. And it's essentially Lisp. That's what Lisp is. You just pass functions, because apparently there's no real objects or anything like that. One example is sorted. If you pass a function to key, then you have a little function there that only does one thing. It only pulls out the key that you want. And that's a really great example. Filter also does a similar thing. Now, the examples to follow. Now, I haven't shown you much code today because there's a lot of, when you get into the proper composition, you do rarely need a bit of complex software to rarely show its benefits. For an example, cryptography. It's the new cryptography thing. There's a talk on tomorrow, I think afternoon, someone's giving, about cooking with cryptography. I highly recommend that you go and see that. It replaces PyCrypto, M2 Crypto, all of those. It works on PyPy. It's implemented using CFFI, which is sort of like the Python C extensions, but it works better on PyPy. And it's really, really great because they're using composition to make pluggable backends. Because not everyone wants to use OpenSSL because it's really insecure. So instead they have backends. And now these backends satisfy an interface. So you have a hash interface. You give it a string and it returns you a hash. It doesn't matter what actually does that as long as it returns that result. So on OS X, for example, it binds to Common Crypto, which is Apple's cryptography framework. On all other platforms, it binds to OpenSSL. And in future, it will bind to LibreSSL on OpenBSD, I think it is. Plus all of the other crypto frameworks like the one in that Microsoft ships in Windows. Because, you know, then it doesn't matter what you're using. You can avoid OpenSSL if you want. And composition gives you the power to switch it out. The Python standard library has a lot of instances of this. For example, sorted and filter, little things like that, things where you don't need to have that much complexity to figure out the benefits. So you should definitely look at all those functions and see they're sort of crept in there. It's a good idea and it's just there. And no one really notices how powerful it is that you just pass a function. The newer parts of Twisted use composition great. Because we have a lot of networking things, we have things like TCP tests, UDP tests, things that think that they're going over a real network. Now, you can't always get a real network. A lot of our build bots are in places where they might not have a network adapter on IPv4. So how can we run the IPv4 tests? Well, we use composition so that it thinks it's talking to a reactor that will actually connect an IPv4 connection. But we just fake that away. It returns a reactor which just runs in memory that isn't actually bound to anything. That is just a good enough approximation for what the tests need to run. And that means that those little sections run incredibly fast. The whole Twisted test suite, which is over 3,000 tests, can run in a minute. And if you turn on parallel jobs, that's even faster. Now that sort of thing is amazing for a software project that is 10 years old and has such a large scope. There are so many protocols, so many tools. We've got a templating framework, we've got TCP, UDP, everything. And yet we can test the whole thing in 60 seconds. I've worked on a project where it was 6 months old and it took 9 minutes to run the tests because of an external I/O dependency. As soon as I replaced this with an in-memory version, it went down to 20 seconds. So that sort of thing is the benefit you could see if you just do things like that. Now, it doesn't have to go everywhere. Now, things that go everywhere is like list. That's the only thing you can do. And that's one of the things that, you know, the Haskell and list and closure and people go on about, is this sort of style of writing software. Now, they might not be correct on a lot of things. I mean, for instance, you know, Python is just better. I mean, I don't care about, you know, how good the JVM is, because Python is what to do. Python is easy. Python is good. But we can take things from these languages that make them better and put them in Python. Now, it works better if you have first-class functions, which in Python we don't really have. But it's good enough. Now, I recommend you try it out. I will be... there's a great talk called The End of Inheritance, New Modularity, something like that. That's at PyCon US in 2013. They do a more in-depth, more computer sciencey look at it. And it's one of the authors of PyLint and another author of Mercurial. So they've been talking about their real-world experience and a more lower-level thing. But I highly do recommend that you look into this, simply because tests are good and having fast tests is better. Fast tests means that people run them more often. It becomes less of a chore. You don't run on your build bots as much, and you do less I/O, so it's less fragile. So give it a shot. And questions?
Right. Those of you who've got any questions, if you'd like to come up to the microphone here and just deliver it. Remember, it is a question and not an opinion at this stage, I think. So.
Yeah, you can probably give some opinions.
Come on up.
There's no Russells to give the first question. Yeah, any question?
You've given some examples where we can see composed code and twisted. Is there somewhere we can search for to get started on this? Are there kind of Google words that we should look for composition to help us get a really introductory start looking at code so we can adapt it in our code?
As far as a guide to it, or sort of how to do it, there's no real Python thing. It's relatively new. I mean, one of the things Russell was going on was, it had a bit of a. It's been coming up more in the past year and a half, so there isn't a lot of the history behind it. There is a lot of history in other languages, especially, which would map pretty well. Things like functional languages basically have this. So if you look at basically how any functional language works and try doing that in Python, you'll have a pretty good approximation. I would recommend just the easiest way is just get a thing that you subclass and try and break that into two objects. One that wraps it and implements your special functionality, and the original class, and then see how you go with that.
Okay. Cool. Thanks.
Hi, so thanks for your talk, and thanks in particular for the concrete example of the blog. It's sort of a classic one, and I think it really added a lot. I was wondering, for a point of comparison, if you had much of a sense of what would that example look like if it were done really badly, like in a inheritance-based view or something like that. Just to.
It depends on. It depends a lot on what framework you're using. For example, a really bad. Let's pull up Emacs. Everyone loves Emacs. Yeah, Emacs. Oh, it's tiny. Okay. Let's pull up text edit, because that's where real men do their programming. Unfortunately, I'm not a real man, so. Okay, so, whoa. Oh, great. Okay, so I will be writing like this. Okay, so with a thing like that. So if we're using Django, so we've got a view. So you go class, my blog, view. So you've got that. So that would be the instance where we had the Flask-like. I'll make that down a bit more. It's really hard.
Sorry, I didn't mean to put you on the spot for a bunch of live coding.
I actually wanted to show this. I actually have a rarely. Actually, I know. Oh, come on, mouse. I actually have an example that I was using that was a Twitter account, which I think demonstrates it rather well. However, I didn't get to put that in the talk. Come on. Yeah, there we go. Okay, so if I zoom in so you can actually read it. So down here we have, this is the worker implementation. Okay, so here you have a Twitter worker interface. So both have this interface. So the composition one works like this. You have requests, you get your tweets. Now, the composition-based Twitter application takes that object and then calls functions on it. that's the tests. Oh, I didn't actually write the other one. Okay, so the inheritance one would actually descend from that, and then would call the objects on itself, rather than taking the Twitter client as a thing that's passed in. So that is generally the worst bit, I would say. Like, that's right then it starts getting really bad, because then you have to monkey patch out the bits that actually talk to Twitter. You can't just fake away all sorts of connections. You have to actually connect to Twitter, which gets really bad when you have APIs and stuff like that. So this, so already you can't really test the logic of your application. You can't test the bits that you've written, because it relies on stuff that other people has written that depends on external services. So I think right then, whenever you're talking to the outside world and you need to do that, it's already a disaster, because it takes so much work to actually get it so that you can run it without that service. So that's what I'd give it. It just gets bad straight away, just from the testability perspective. Of course, if you don't care about tests, then sure, it works, whatever. YOLO. So, but yes, thanks.
Thanks.
Well, thank you very much indeed, Amber. Each year, the committee goes to great lengths to award the speakers at the PyCon. This year, a few of them went out into China and Beijing. They found a little marketplace selling Ming Dynasty ceramics. And we all know that Amber drinks Earl Grey tea only.
Oh, yes.
And so this priceless artifact there, thank you very much indeed. Oh, shit, that looks awful.
Thank you. Thank you, everyone. If you have comments you want to say at me or questions, I will be around all the conference plus Monday, Tuesday. So happy to talk about it. Happy to meet you. You're all wonderful. Thank you for not going to Russell's talk, because I thought that I would have like 3 people here because it's Russell. So yes, thank you.